All right, let me show you. Okay. Students always ask me, Mr. Bazzi, how do we know whether, two samples are dependent and independent? And I tell them, if you see something like that, same number of people, an action, old and new, before, after, right away, you should be able to tell that the samples are dependent. And let's see. A shoe manufacturer claims that the athletes can increase their vertical jump heights using the manufacturer training shoes. So the manufacturer is claiming if athletes use their shoes, they can increase their vertical jump heights. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the training shoes for 8 months, their vertical jumps are measured again. So you can see this is before they use the manufacturer shoes. This is how high they can jump. And this is after they used the shoes and they trained for 8 months. Your new vertical jump right here. The vertical jump heights in inches for each athlete are shown in the table. Assuming that the vertical jump heights are normally distributed, so the population are normally distributed, so we're safe to use any test now. Is there enough evidence to support the manufacturer claim at alpha equals 10%? And this exercise was adapted from Coach's Sports Publishing. Okay. First of all, guys, you have to agree that the samples are dependent because the 24 and 26 are related, guys. Why? Because they come from the same athlete. This is how high this athlete could jump without the manufacturer's shoes, and this is how high he could jump with the manufacturer's shoes. So it's the same person before and after. So the samples are dependent. That's very, very important to realize that. And then after we realize that the samples are dependent, then I'm going to show you how do we perform the test. Okay. Let me ask you a question, you guys. For athlete number 1, do you think the manufacturer's shoes helped? Yes or no?
It does.
By how much?
2.
By 2. Do you guys agree by 2? Okay. So if you subtract 24 minus 26, yeah, that's a negative. Okay, I'm going to do the difference here. So it went up 2 units. That's right. What about athlete number 2? Did it help? Yeah, it did help. 22, it went up to 25. And if you do the difference, it's -3. You notice I put the difference here. So that's step number 1, guys, that you have to do when you perform this test.
So we have to subtract the new one from the old one?
No, it's first minus second. I'm not just going to do the practice. This first line minus second line, always.
Okay.
What do you think, athlete number 3, guys? You agree with me? It didn't make a difference, correct? 0. Athlete number 4, did it improve? He went from 28 to 29. So do you guys agree with me? If it improved, the difference is negative. It seems like if it did make a difference, then the difference must be negative because you want the new numbers to be higher than the old number. What about athlete number 5? What's 35 minus 33? 2. Do you guys agree with me that for athlete number 5, it didn't work at all? Actually, it worked in reverse order. This guy was making 35 inches and now he's making 33 inches. So it has a negative effect, just on the performance of athlete number 5. What about 6? 32 minus 34, guys, is what? -2. All right. 30 minus 35. It seems like the one that benefit the most is number 7. 30 minus 35, it went up by 5. 27 minus 30, -3. All right. I'd like you guys to forget about the old, the new, this one. Forget about it. Forget about this. And I'd like you just to focus on this, the difference. And that's what we're going to test. So actually, guys, this two sample test is going to turn out to be one sample test, which is testing the difference only. Okay. Do you guys agree with me that if if the shoe manufacturer claim is valid, the difference should be negative between the old and the new? Because if it is valid, let me give you an example. If someone was making, let's say, 25 inches before using the shoes, if the manufacturer shoes help, then they should make more height vertical jump. So let's say 29. And if you do 29 minus 25 minus 29, you're going to get a negative number. So if the difference is negative, that means it is working, because when the difference is negative, that means the new number is higher than the old number. Then old minus new will be negative. So when we do the difference between the two sets, this is how we test the claim. We test the claim whether the difference is less than zero, or the difference is greater than zero, or the difference is not equal to zero. So it's all against zero. It's going to be a claim against zero, whether we go above the zero with the difference, we go below zero with the difference, etc. And we're going to be testing the claim of on this set. We're going to forget about this one. We're done with this already. Now I have the difference. Just ask yourself, do I want the difference to be negative, or I want the difference to be positive, or I want the difference to be equal to zero, etc. Since we know if the larger number is bigger than the smaller number, that means the claim of the manufacturer is working. And if you know, if you have a smaller number, guys, and subtract a larger number, you get a negative answer. So what we need to test that the difference is negative. And here is how we state the claims here. There are three sets of claims that you have to select one of them. So I'm going to go here, guys, and show you how to state the claims. You put mean of the difference. And this is how the book uses it. It put the mean sign and then D to refer to the difference, because we're using only the difference between two sets. And that could be equal to zero, not equal to zero. That's one scenario. The other scenario, guys, will be this: greater than zero. And then the last scenario, guys, will be that. And for our case, guys, it's going to be this scenario. Why? Because we want the difference to be negative. That's the old minus new. We want that to be negative, and that's what we're going to test. And this is how you state the null and the alternative hypothesis. You always select one of the three here, either this set or that set or the third one. And for step number one, HO, HA, it's going to be. Another hint I give students, they tell me we get confused whether we put less than zero or greater than zero here, etc. I tell them what do you notice the prevailing difference here? They tell me negative. Then I said, probably it's very likely that that's what we need to test. So always take the first set, guys, minus the second one. I'm basing, just all of my teaching for this section based on that. You do the first one minus the second. So, and that's how the book does it. The first minus the second. So, and this is our claim. That's the manufacturer claim right here. I mean, it seems like it is working for many of the athletes. For one athlete, it didn't work. For this athlete, it didn't work at all. Actually, he's doing worse, just with the shoes. But for the remaining 6 athletes, it did work. Look, their vertical jump increased 24 to 26, 22 to went up to 25. 35, 32 went up to 34, 30 went up to 35, 27 went up to 30. So let's see if as an overall this works. So here's what you do, guys. You're gonna input this data into L1, the difference. So let's input the data into L1. Let me clear my lists, just show you the lists nice and clear. It's very simple to input the data. So -2, -3, 0, -1, 2, -2, -5, and then -3. Here you go, guys. And can you guys guess what test are we going to be using here? It's one sample, not two sample anymore. Any guesses? It's not a two sample t-test. It's just a t-test, guys. One sample. And data. It's always data because you have the data set. And it's always against 0. So on the right-hand side, it's going to be always 0 for this section. Look, guys, the 0 right here. And my list is in L1, so I'm just going to change this 1 second and then number 1. And we're doing less than 0, less than. And let's do a draw, if you like. Let's see what the p-value is. So the test statistics is -2.333, and the p-value is small, guys. It's 0.0262. So t-test. And I'm going to just write down what we did here. Data, list, L1, frequency 1. We did mu0 is 0. And mu we did less than. All right. So t is -2.333. P-value is 0.0262. And what's alpha, guys? Alpha, he says 10%, so it is less than 10%. Reject HO. You know, students always will tell me when it comes to this section, it says he's asking for increase, and then you're telling us we have to test for negative, because the students in their mind thinking that increase means a positive. Yeah, for the new number, it is more. Yes, it's going more. But when you do the difference, guys, old minus a new, you need to get negative, because if the new number is bigger than the old number, the difference must be negative. So it's always the opposite when you test it. If it says the word increase in the problem, you want to do less than 0. If it says decrease, you want to do greater than 0, and so on and so forth. So there is enough evidence at the 10% level of significance to support the manufacturer claim. That means, yes, their shoes do work, that their training shoes increase vertical jump. And that's how you perform this test, guys. Any questions right here? So step number 1, guys, you have to do the difference and forget about the first set and the second set. This is not data. These are the names of the athletes. Athlete 1, 2, 3, 4, 5, 6, 7, 8. The data is right here, guys. And then you decide on one of those 3. guys. You just have to decide whether you select this or that or that, and then you perform a t-test against 0. Okay, and just to go back now to the introduction, the conditions of the test: the samples must be randomly selected, they must be dependent, and the population must be normally distributed, or at least the sample size is at least 30. Well, here he gave me a sample size of 8, but he mentioned that the populations are normally distributed. And then you always do the difference, guys, and use a t-test against for mu of t. Okay, let's do another one and show you how just to strengthen what we just learned with this exercise. So let me just do another one. 9 students took the set. Their scores are listed below. Later on, they took a test preparation course and retook the set. Their new scores are listed below. Test the claim that the test preparation had no effect on their scores. That means the training that they did to retake the set did not make any difference. Use alpha equals 0.05. Okay, this is what we do, guys. So we're gonna do the difference D, and you're gonna help me. First of all, you have to agree that those two sets are dependent, and they are dependent because this is the score of student 1 before the training and after the test preparation. Before and after, before and after, before and after. Okay. 720 minus 740, guys, is negative 20. 860 minus 860 is 0. 850 minus 840 is 10. 880 minus 920 is negative 40. 860 minus 890 is negative 30. 710 minus 720 is negative 10. 850 is 10. 1200 minus 1240 is negative 40. And 950 minus 970 is negative 20. So someone is making the claim that the test preparation had no effect. Okay. If I show you guys the four statement, the three scenarios, we need to select one of them. What do you think it is? We're saying that the test preparation did not make any difference. When I say there is no difference, that means the difference is what?
0, which is the
Zero,
first.
exactly. So it's going to be first one. When I say there is no difference between my score before the training and my score after the training, I'm claiming that means the difference is 0. I mean, it's not going to be exactly 0, but that's what I'm claiming here. Now, if you notice, guys, yeah, there is a difference, but the negative 20 is negative 20 substantially, not just enough to say that there is a difference. For example, guys, if you score like 65% on a test, and then you told me, Mr. Bazi, I'm going to make efforts to improve my score, and then on the next attempt you score 66, the question is the 1% significant enough to say that you improved? Probably not. Probably not. And here at 20 points, is it big enough to say that it did make a difference? Probably it didn't. So that's what we need to check. So when he says had no effect, guys, had no difference, you know that you're doing this one. If I give you the same question, guys, and I ask you, test the claim that the test preparation helped students increase their score, which one would it be? It won't
The
be
second one.
The third one.
the third one. I know increase, you guys, you thought greater than 0. If it increased, that means if they had a low score before, then after they have a higher score. And remember, guys, low minus high is negative. When you take a smaller score, subtract a larger score, you should get a negative answer. So it's always the opposite of what you read. You read increase, you do negative. You do read decrease, you do positive. But in our case, guys, it's just going to be here because it says had no effect. It will be this one. And now we go to the calculator. Let me just show you. You go to stat edit. Let me just put him in L2, negative 20, 0, 10, negative 40, negative 30, negative 10, 10, negative 40, negative 20. There you go. And now go to stat, tests, t-test, guys. We're back to one test. Against 0, I have L2 here. And not equal to, look, that's the alternative hypothesis. And I'm gonna hit draw. Okay, so T is negative 2.401 and the p-value is 0.0431. Here you go, guys, which is less than alpha, so we reject HO. And there is sufficient evidence at the 5% level of significance to reject the claim that the test preparation had no effects. That means it did have an effect. We're rejecting the claim that it didn't make a difference. So that means it did make a difference. So yes, it did make a difference in the scores. There is sufficient evidence to reject the claim. And why we didn't say the word support, because the claim is in HO. So we use the word reject the claim. And these are the screenshots of the calculator. So that's another example. There's one more example, guys, that we didn't do yesterday from the review exercises. It's right here. This one. Exercise 5. A physical education director claims by taking a special vitamin, a weightlifter can increase his strength. 8 athletes are selected and given a test of strength. Using the standard bench press. After 2 weeks of regular training supplemented with the vitamins, they are tested again. So this is before taking the vitamin and this is after taking the vitamins. And probably I could have put here athlete number 1, 2, 3, 4, 5, 6, 7, and 8. Test the effectiveness of the vitamin regimen at alpha equal 5%. So is it effective? So we're gonna need to do the difference, guys. We're gonna subtract -9, -6, 3. So here it helped, here it didn't help. Here it didn't help. 262 minus 270, it helped, it went up by 8 points. It went down, -3, went up, and no change. Okay, and can you guys tell me which one is it gonna be?
Third one also.
The third one again. Again, the word increase, guys, is you need to test that. You want the difference to be negative. Here is another way, guys, to figure it out. Don't look at this even to get a hint, because here you see positive and negative. It's a little bit confused. Look, this is how I tell my students always to figure out the alternative sign. I tell them, just put a number to begin with. Put any numbers. So they said, okay, let's put 75. And I said, the manufacturer is saying here, they claiming that this special, just treatment will increase the strength. So increase, that means you have to go higher than 75. Put a number which is higher than 75. Then they tell me 80. I said, great. And then I tell them subtract. So we're not looking here. We're just making this up. They subtract 75 minus 80, guys, they get -5. And then I ask my students, is -5 positive or negative? They tell me negative. I said, this is your test. That's mu of t less than 0. You can see the negative is prevailing here, so probably that's a hint for you that it should be the negative. And now, guys, we're going to go to L1. Whatever, we'll just put them in any list. I'll keep those for my later group, so I'm going to just put them in L3. And remember, guys, the negative sign, you have to use the negative from the bottom right here. Right here. So let's put him there. -6, 3, 1, -8, 3, -3, and then 0. Okay. Go to stat, tests, t-test, data, L3. Well, how do I select L3? I just press the second key, guys, and number 3. And then we're testing less than 0. Oh, that's a big p-value. So T is -1.388. And look at the p-value, guys, it's about 10%. So we're going to fail to reject the null hypothesis. If you just wonder what this one, that means approximately. We can never get an exact value for p-value or T. But if you put equal, that's fine. When they ask you to round, that's it. You can put equal, which is more than alpha, guys. You fail to reject HO. And the conclusion, there is not enough evidence at the 0.05 level of significance to what, guys? There's not enough evidence at the 0.05 level of significance to support the claim. Support the claim by the physical education director. That by taking a special vitamin, a weightlifter can increase his strength. That a special vitamin can increase a weightlifter strength. So if you can do a study, guys, if somebody makes a claim, you can verify that their claim is not valid, you can publish the results and get those people in trouble, just who are making false claims. And that's why hypothesis testing is very, very important. Sometimes they tweak the claim, just to work to their advantage, and probably they don't meet the requirements, just to do the claim. This is all stuff that you have to be careful with. Were the samples random? That's another question that you would ask. Were the samples dependent? Was the population normally distributed? So they have to meet all those conditions in order to perform the test. I'm going to do one more of this section because, as I told you, this is very, very important section. You will definitely see a question from this section on the next test and on the final exam. 8.3 is important. It's about dependent samples. And I'm going to select one more problem from the book to show you how this works. There are too many questions there. So let's pick another one. Okay, let's do number 17. It's on page 445. He doesn't do that using the p-value approach. The solution is using the critical value, but we're going to use the p-value approach for this one. Okay, let's read this question together and try to do it. All right. A company claims that this is page 445, number 17, guys. A company claims that its consumer product rating 0-10 have changed from last year to this year. The table shows the company's product rating from the same 8 consumers for last year and this year. At alpha equals 5%, is there enough evidence to support the company's claim? When he says, is there enough evidence, guys, to support the company's claim, be assured that the claim must be in the alternative hypothesis. We only can ask questions about supporting a claim if the claim is in the alternative. And we ask a question whether we should reject a claim if the claim is in the null hypothesis. So let's do the difference now and make it a list. Let's do the difference. So we do the difference here. D. 5 minus 5 is 0. 7 minus 9 is -2. 2 minus 4 is -2. 3 minus 6 is -3. Then 0. 10 minus 9 is 1. 8 minus 9 is -1. And 7 minus 8 is -1. I'm going to put the 3 scenarios in front of you guys and tell me which one you're going to select based on what he asked. That's one. That's the second. So that's the beauty of the questions in chapter 8. You don't have to, you only have 3 choices for the null and the alternative. Just select one of them. You don't have to make them up. Okay. They claim that the rating have changed. They didn't say whether it is a positive increased or decreased. So guys, what would that be? First, second, or third? Have changed.
The first one?
The first one.
Second or third?
No, the second or third is you have to specify whether the change is positive or negative. But when he says have it changed, they're saying it could be changed to the better or changed to the worse. We don't know. So when this is the case, when something changes, that means they're not the same anymore. So the difference is they're different from each other. You choose the first one. Now, let me tell you when you would choose. Let me just change the wording, guys. Let's say I give you the same question on the test and I change this. A company claims that its consumer products have increased, the ratings have increased. Then what would be your null and alternative? Increase, guys, that means this is how you should think about it. Forget about this. If they say the rating have increased, this is what I would do if I were you. I'll just put one rating to begin with and increase it later. Make it 7. And subtract 5 minus 7, guys. What is 5 minus 7 is negative. Then it would be this one. Now, let's say I ask you the same question on the test and I say, a company claims that its consumer product rating have decreased. The ratings have decreased. Here's how you figure it out, guys. Put a rating to begin with. Let's say put 6. And then the company claiming that the rating have decreased, come up with a rating that is below the 6 because they're saying decreased. Just put 5. Any number below 6. And then subtract 6 minus 5, guys. What is 6 minus 5? 1. 1 is positive. That means you test greater than 0. But if he says it changed, neither positive nor negative, you just do different from 0, and that should be our, and this is the claim right here. Okay, and now we're going to put the data into L1. We're just going to input this in L1 and show you how to process this information. Watch. Edit. Okay, I'll put him in L4. 0, -2, -2, -3, 0, 1, -1, -1. I mean, to me, it looks like the rating have changed. Let's see. Stat, tests, t-test, data, mu0. I'm gonna have to put L4, guys, here. Not equal to 0. And then hit calculate. Okay. So T is -2.16 and the p-value is 0.0676. And he wants that at alpha 5%. So actually, no. T is -2.160. P-value is, guys, 0.0676, which is more than alpha. So we fail to reject HO. And you conclude there is not enough evidence at the 0.05 level of significance to support the claim that the rating has changed. So this is how we do that. I would like you also to look at the calculator, guys, and what, in addition of the test statistic and the p-value, it gave you two more input here. It says x bar equals -1. Let me tell you what this is the mean of the differences. You see, if you add those values and divide by 8, you will get -1. And if you find the standard deviation of those values, you will get this. Because when you do your homework online for chapter 8, sometimes he will ask you to do the difference and ask you to find the sample mean and the sample standard deviation. They're done for you right here. So that's S and that's X bar. If you want to do them separately, you can. You can go to stat calc, if you remember from chapter 2, guys. One variable statistic, and it's L4. And watch, we're going to get the same thing. That's X bar, which is -1. And that's S, which is the standard deviation, 1.31. We don't look at sigma because we know that this is a sample. It came from a sample. Okay, so that's that concludes our discussion of section 8.3. In summary, in section 8.3, guys, when you see any data sets like this put in a table format, I can assure you they will be like that, either horizontal table or vertical table, guys. You subtract the first one minus the second one, you get a new set, call it the difference, and run a t-test on the difference against 0. So on the right-hand side, you'll always have one of those options, guys. You select one of them, the proper one, and you run a t-test, simply a t-test. Okay.